It might sound trite to say that the universe is full of mysteries. But it's true. Chief among them are things like dark matter, dark energy, and of course, our old friends, the black holes. Black holes may be the most interesting of them all, and the effort to understand them, and observe them, is ongoing. That effort will be ramped up in April, when the Event Horizon Telescope, EHT, attempts to capture our first image of a black hole and its event horizon. The target of the EHT is none other than Sagittarius A, the monster black hole that lies in the center of our Milky Way galaxy. Though the EHT will spend 10 days gathering the data, the actual image won't be finished processing and available until 2018. The EHT is not a single telescope, but a number of radio telescopes around the world all linked together. The EHT includes superstars of the astronomy world like the Atacama Large Millimeter Array (ALMA), as well as lesser-known scopes like the South Pole Telescope (SPT). Advances in Very Long Baseline Interferometry (VLBI) have made it possible to connect all these telescopes together so that they act like one big scope the size of Earth. The ALMA Array in Chile. Once ALMA was added to the Event Horizon Telescope, it increased the EHT's power by a factor of 10. Image, ALMA, SONAOJNRAO, Odesiba. The combined power of all these telescopes is essential because even though the EHT's target, Sagittarius A, has over 4 million times the mass of our Sun, it's 26,000 light-years away from Earth. It's also only about 20 million km across. Huge but tiny. The EHT is impressive for a number of reasons. In order to function, each of the component telescopes is calibrated with an atomic clock. These clocks keep time to an accuracy of about a trillionth of a second per second. The effort requires an army of hard drives, all of which will be transported via jetliner to the Haystack Observatory at MIT for processing. That processing requires what's called a grid computer, which is a sort of virtual supercomputer comprised of 800 CPUs. But once the EHT has done its thing, what will we see? What we might see when we finally get this image is based on the work of three big names in physics: Einstein, Schwarzschild, and Hawking. A simulation of what the EHT might show us. Image, Event Horizon Telescope Organization. As gas and dust approach the black hole, they speed up. They don't just speed up a little, they speed up a lot, and that makes them emit energy, which we can see. That would be the crescent of light in the image above. The black blob would be a shadow cast over the light by the hole itself. Einstein didn't exactly predict the existence of black holes, but his theory of general relativity did. It was the work of one of his contemporaries, Karl Schwarzschild, that actually nailed down how a black hole might work. Fast forward to the 1970s and the work of Stephen Hawking, who predicted what's known as Hawking radiation. Taken together, the three give us an idea of what we might see when the EHT finally captures and processes its data. Einstein's general relativity predicted that supermassive stars would warp space-time enough that not even light could escape them. Schwarzschild's work was based on Einstein's equations and revealed that black holes will have event horizons. No light emitted from inside the event horizon can reach an outside observer. And Hawking radiation is the theorized black-body radiation that is predicted to be released by black holes. The power of the EHT will help us clarify our understanding of black holes enormously. If we see what we think we'll see, it confirms Einstein's theory of general relativity, a theory which has been confirmed observationally over and over. If EHT sees something else, something we didn't expect at all, then that means Einstein's general relativity got it wrong. Not only that, but it means we don't really understand gravity. In physics circles they say that it's never smart to bet against Einstein. He's been proven right time and time again. To find out if he was right again, we'll have to wait until 2018.